Hello and welcome to Static Volume Provisioning. My name is Srinath Challa. I'm a certified Kubernetes administrator. So in the next few minutes, I'll try my best to explain what is static volume provisioning and how it is created. But before you watch this video, it is required to have a basic understanding of what is persistent volumes. In case if you need help with that, please do check links to those videos in the description below. So, without any further delay, let's take a look at the things you'll be learning as part of this video. This video primarily consists of two parts. In part 1, we'll discuss about the overview of static volume provisioning in Kubernetes. So once we get an idea of it, then we will move on to the review demo section. So in review demo section, we will first create the persistent volume. Then we will create the persistent volume claim to claim the persistent volume that we just created above. After that, we will use this claim inside the pod and deploy it. And finally, we will test the use case of static persistent volume. So let's get started with going through overview of static persistent volume. There are two ways to provision storage in Kubernetes. First, static provisioning, and second, dynamic provisioning. This video is completely focused on static provisioning, and there is another dedicated video which explains about dynamic provisioning, and link to that video is provided in the description below. The name it got static provisioning is we need to create the persistence volume in advance before we create the persistence volume claim. In case if you're not familiar about what this persistence volume and persistence volume claim is, in short, PV and PVC. So at a very high level, persistence volume is a storage chunk inside the Kubernetes. These persistence volumes are created typically by storage admins. Next, persistence volume claim. PVC is a request made to the storage. Typically, developer requests for the storage. So that's about the persistence volume and persistence volume claim. And it is very important to get a clear idea what these are. In case if you need a detailed explanation about this, then please do check out the persistence volume video. A link to that video is provided in the description below. So that's about the static provisioning. So to understand this better, let's take a look at the complete process of it now. Let's imagine that you have a storage infrastructure with different types of storage such as fast speed SSDs, slow speed hard disks, NFS, and then object storage. So first thing in this process is to create the persistence volumes, which is done by an administrator. In this example, admin has created the storage chunks of different capacity. These storage chunks are called as persistence volumes. So as and when needed, developer can create the persistence volume claim or simply PVC to request the storage from this pool. Let's say for example, developer has requested for 2 GB of fast speed SSD storage by creating the PVC. Then PV claim gets bounded to the 2 GB PV. Now developer can make use of this bounded PVC inside the pod. But there is one problem with it. What if the size of requested storage doesn't match with one in available pool? Unfortunately, developer has to wait till admin to create the right size what developer needs it. That's when dynamic PV comes into the picture. And we'll discuss about dynamic provisioning in a separate video. And moving on to the next slide. To give you a high level overview of upcoming slides, it's primarily divided into 4 sections. It starts with creating persistence volume. Then we'll create the persistence volume claim to claim the persistence volume that we just created above. Then we will reference that claim inside the pod. And finally, we'll test the use case of it. And now, let's start with creating persistence volume. Creating PV is the first step in this process. So to briefly explain, persistence volume is a piece of storage. If you are familiar with STAN or NAS, then I guess you must be aware of LUN. So persistence volume is kind of a LUN in Kubernetes world. And this is usually created by administrators. Persistence volume is often called as, in short, PV. In next 2 slides, we'll discuss about PV config file, then we'll create it and display the PV. And now let's see what it contains in the PV config file in next slide. Like any other object config file, PV config file contains 4 top sections. It is API version, kind, metadata, and spec. PV is part of initial stable release. So the API version for this is v1. The kind of object we are creating here is persistent volume. Next, name of this persistence volume in our example is PVGCE. Now comes the spec section. This is where all core part lies. This spec section contains 4 major parts. It starts with capacity, and this is where we define how much storage this persistent volume should be. In our example, we have the size around 12 gig. Next comes the access modes. There are different access modes such as read-write once, read-only many, and read-write many. In our example, we have read-write once. It means the volume can be mounted as read-write by a single node. Then next comes the storage class name. And this is kind of a tag you are giving to the backend storage. For example, if you have a SSDs, then you can define the storage class name as fast. If you have a regular magnetic disks, then you can define the storage class as slow. And also, this plays a major critical role when defining the persistence volume claim. And we'll discuss about that in next few minutes. Finally, we will have the backend disk name. In case if you have the backend persistent disk which is on Google Cloud, then the disk type you are defining here should be GCE persistent disk. In case if the disk is based on AWS, then you define here is AWS Elastic Block Store. So in this example, we'll be using the disk based on Google Cloud because all my Kubernetes setup is running on Google VM instances. Next, we need to define the disk name we have created on Google Cloud. So when you create this disk, it will give you the raw disk and you need to format it with some kind of a file system type. And finally, you will provide the file system type here. In our example, we will format that disk using ext4 file system. That's it. You have a spec file for the persistent volume ready. Now you need to create it, and let's do that in next slide. We will create the PV by running kubectl create command followed by F option with a file name. As you see, something went wrong. Looks like my data disk which we have defined in PV config file is not created yet. So you need to first create that disk on Google Cloud before you actually reference it in PV config file. So the disk size you create on Google Cloud shall be equal or little over than what you reference in the pod config file. So here is a screenshot of my data disk of size 15 gig. So now we can rerun the kubectl create command to create this PV. So to verify if the PV has been created or not, then we need to run the kubectl get command, and which we will see in the next slide. Here in this slide, we'll see the details of the PV which we have created. To display higher level details of persistence volume, you can use kubectl get command followed by PV, and this will display all PVs inside the Kubernetes cluster. From the output you can see capacity of this PV is 15 gig and it is read-write once access, and status is available and storage class is slow. Now to see the complete details of this PV, we need to run the kubectl describe command followed by PV and PV name. Here in this case, PVGCE is the name of the PV. So one thing to highlight in this output is the backend disk source. From that, we can see the backend disk is a GCE persistent disk on Google Compute Engine. Next, disk name is my data disk and formatted that disk using ext4 file system. So far, we have completed our first step, which is creating the persistence volume. And this step is typically done by an administrator. Next step in this process is claiming this persistence volume. Now, let's move on to the next slide. So to briefly explain about the persistence volume claim, it is a request for the storage capacity by a developer. So in the first step, admin creates this PV. Next, developer comes in and claims this storage by creating the persistence volume claim. So in next 3 slides, we'll create and display the PVC config. Now it is time to create PVC. We have already created the PV and you can see that PV here. Like any other object config file, PVC config file contains 4 top sections. It is API version, kind, metadata and spec. PVC is part of initial stable release. So the API version for this is v1. The kind of object we are creating here is persistence volume claim. Next, name of the persistence volume claim. In our example, it is my disk claim. Now comes the spec section, and this is where all core part lies. And let's take a step back now, and the reason behind this is PVC is for requesting for the resources. Typically, developer requests for the resources by creating the PVC. Here, this PVC requests for the storage of 15 gig. And finally, we will have the access modes and the storage class name. Here, PV can only bound to the PVC if the storage class name should match. In case if you don't define the storage class name, PV will not bound to the PVC. So that's it about the PVC config file, and now it's time to create this config. You can create the PVC using kubectl create command followed by config file name. So to display the PVC, we can run the kubectl get PVC, which will display all PVCs. From the output, you can see the PVC is bounded to the PV. Now, you can also display the PV using kubectl get PV. As you can see, PV is bounded and the claim name is my disk claim. So far, we have created PV and PVC. And now, one last thing to do is claiming the PVC inside the pod. In next 2 slides, we'll create and display the pod where we will reference the persistence volume claim that we just created. We already have persistence volume and persistence volume claim. As I said earlier, now we need to claim persistence volume claim inside the pod deployment. Here we have the pod config. So now to claim the volume inside the pod, we need to define the volume type, which is persistent volume claim. And the claim name here is my disk claim. That's it. Next, we need to create this pod. Now, to create this pod, we'll use the kubectl create command followed by f option and the pod config file name. Now, let's display the pod using kubectl get pods. From the output, you can see the pod is running on node ending with FQ or 0. And one more validation. Here is a screenshot from Google Cloud Platform. As you can see, my data disk is assigned to the node where the pod is scheduled. With this step, we have all the setup in place to test the use case. We have created the PV, then PVC, and finally, we claimed the PVC inside the pod. Now, let's start the testing. Here, we'll go through the steps involved in the testing use cases of persistent volume. The purpose of persistent volume is to have data persistent on the backend disk, irrespective of node failure, unexpected reboots, shutdown, and any interruptions to our pod or node where this pod is running. And we expect to have our data inside that disk is safe across all the issues. So to test this use case, we'll first create the test file inside the disk where it is mounted. And we will have to do that by going inside the pod. Next, we create one sample test file with some content in it. Once that is done, we'll delete that pod. Next, even if the pod is deleted, we expect that data still be there on my data disk on Google Cloud. Next, we will recreate the pod with same configuration. And finally, we will verify the data that we have created in step 2 is still available. And now let's start with step 1. So in step 1, we'll go inside the pod and create the test file. You can go inside the pod by running kubectl exec command followed by pod name. Here, we need to pass the options such as interactive terminal and the shell prompt that we need. After you are inside the pod, you can check the mount point test PD by doing the df. And the output confirms that mount point exists. Then, we will create the sample test file called test1.txt with some content in it. After that, we will exit from the pod. Next step is to delete the pod. We can do that by using kubectl delete command followed by F option with file name. Output confirms that pod is deleted. Also, you can see the my data disk is not in use by any node. Next step is to recreate the pod with same configuration and same disk. To recreate the pod, we can do that by executing kubectl create command followed by pod object config file. Once that is done, you can verify the status of this pod by kubectl get command. Output confirms that pod is scheduled on node ending with FQR0 and running successfully. Also, you can see the my data disk is marked as in use by node where the pod is scheduled. Since we are using the same disk, we expect to have our data still be there from our previous testing. Let's check that out in next slide. First, let's make sure the volume is mounted on test PD location inside the pod. We can do that by running kubectl exec command. From the output, it is mounted. Next, let's do the ls on that mount to make sure our test1 file which we created from our initial test is still there. We can do that by using same kubectl exec command with ls. As you can see in the output, our test1.html file is still there. Finally, let's get that file by running kubectl exec command. Yes, contents are still the same. And this comes to our end of our testing. And it is passed. And now it's time to clean up the things that we have created in this video. There are 3 objects that we have touched in this video. First, let's delete the pod. Then we'll delete the PVC. And finally, we'll delete the PV. Once all this is gone, you can see from our screenshot, my data disk is not in use by any node inside the cluster. And coming to summary of this video, in the concept section, we have discussed about how persistence volumes are provisioned. And we have discussed about 3 primary steps involved in this process, which are: first, typically administrators will create the persistence volume and adds that to the storage pool. Then, developer requests the storage by creating the persistence volume claim. And finally, developer can make use of this PVC as a storage volume to mount inside the pod. So, after we got an idea of creating static provisioning volume, then we moved on to the review demo section. So in the review demo section, we first created the persistent volume. Then we have created the PVC. After that, we have used this PVC inside our pod and deployed that pod. And finally, we have tested some of the use cases of static persistent volume provisioning. And now it's time to move on to the next video, and which is live demo of static volume provisioning. In that video, we'll perform the exact steps that we have discussed in the review demo section on live Kubernetes cluster. And link to that video is provided in the description below. And finally, thank you so much for watching this and hope to see you in the next video.